Hey scholars, Ms. Beglin here. In reviewing your Unit 1, Lesson 3 asynchronous work, I noticed a common mistake in the majority of responses, and so I decided to use today's asynchronous time to address that mistake. So this scholar, like most of you, has demonstrated proficiency with dissociating ionic compounds, using the double displacement reaction to predict the products of this reaction, or the double displacement method to predict the products of this reaction, using the solubility rules to identify which product is insoluble, and identifying and eliminating spectator ions to write the net ion equation. This scholar, like most of you, has mastered the AP chemistry content of this problem, but is struggling with the pre-AP chemistry content of balancing atoms and charges, which we can see here. And that's okay, because this was a common mistake that we made. That's why I'm making this video. So let's walk through a revision of the scholar's work. Write the balanced chemical reaction and net ionic equation for the following reaction. FeCl3 reacts with KOH to form something, and we're going to find out what something is. I'm going to dissociate my ionic compounds. Remember, ionic compounds consist of ions. They are charged. We want to indicate those charges, but I don't know the charge of iron because it's a transition metal. Okay, well, let's keep going. And I have 3 Cl minuses. Scholars, some of you may be wondering, wait, why did you write it as 3 Cl minus and not Cl3 minus? Cl3 minus would indicate 3 chlorines covalently bonded together, all sharing a negative charge. This doesn't exist. In ionic formulas, subscripts generally indicate how many individual units we have. So this is telling me I have 3 Cl minuses. The exception is polyatomic ions, which are covalently bonded and so act as 1 unit. So I have 3 Cl minus. I know it's Cl minus 1 because Cl is in group 7 and those elements always form anions with a -1 charge. And I have 3 of them. So if I have 3 Cl minus, that means I have a total negative charge of 3. My total positive charge must be +3 to balance it out. So my Fe is going to have a +3 charge. Plus potassium, which always forms a +1 charge, and our hydroxide, which we should recognize as a polyatomic ion, that always has a -1 charge. I'm going to use my crisscross rule. So I'm going to combine my K and my Cl. So I get KCl because the charge on K is +1, the charge on Cl is -1. They cancel out just the way they are. Plus, I'm going to use double displacement to pair up my iron and my hydroxide. Let's bring it over here. Again, using my crisscross rule to balance my charges, I get that this compound is FeOH3, solid. Because if I have Fe3 plus and I'm combining it with OH1 minus, I need 2 more OH minuses for these charges to balance. Now I do have to balance the chemical equation. So let's do KCl AQ plus FeOH3 solid. I'm going to need 3 KOHs so that I have 3 OH on both sides. And I'm going to need 3 KCls so that I have 3 Ks and 3 Cls on both sides. This is our balanced chemical reaction. And then our net ionic equation would be when we eliminate the spectator ions, we get Fe3 plus 3OH minus. This 3 will apply to both of them. Forms FeOH3 solid. And just so it's clear how this balanced equation plays out, the 3 applies to both species, which is where we get our 3OH minus from. So scholars, that's it. That was the most common error in the Unit 1, Lesson 3 async prep work. Please revise your work on practice problems 2 and 3, and I will see you all tomorrow. Bye, scholars.